Welcome to our webinar presentation on the work of the traditional blacksmith in the modern age. Just briefly to explain a bit about myself, tell you a bit about myself. I'm a chartered mechanical engineer. I started work back in 2007 as a graduate, and around 2009, towards the end of 2009, I started training part-time as a blacksmith. That's really just something that interested me. I basically have done bits and pieces on that while I was training, and then when I finished my training back in 2016, I think it was, and I've basically been doing homers and bits and pieces on the side in addition to my sensible day job as a mechanical engineer. And around the start of last year, March, April time, I decided that I would actually go ahead and make it a full-time occupation, or nearly full-time. So I decided to start a new business called Highland Forge as a full-time blacksmith. And around the time that I started the business, I had a few people ask me or say to me, is that not a huge deviation from engineering? Physically speaking, being an engineer, obviously, you spend most of your time at a desk or in a relatively clean workshop environment, and being a blacksmith, you've got a hammer in your hand a lot of the time, and you're working in front of a fire and an anvil. So physically speaking, there is a fair difference, and there is a difference in the way that you look at it as well. The man who trained me, he commented that one of the hardest things about training me was the fact that I already had my training as a mechanical engineer. So effectively, he had to train the engineer out of me and turn me into a blacksmith. But at the same time, when I think about it, in practice, it isn't actually that different. There are similarities, and ultimately, the blacksmiths, well, they are the mechanical engineers of the past. So I thought I'd have a bit of a chat about that with you today. Now, I think the first thing we'll do is we'll have a look at some of the interesting processes, well, a couple of interesting processes that are used by traditional blacksmiths, or were used by traditional blacksmiths, and to a certain extent are still in use today. And we'll use that to draw a comparison. You'll see echoes from some of these processes in modern engineering, and we'll use that to draw a comparison. And you'll basically, it'll show you how blacksmithing is the origin of modern day engineering. And then we'll have a look at that, and we'll see if there's anything else that could inform engineers. So the first one is fire welding. Fire welding basically is the heating up of two pieces of metal, two pieces of iron traditionally. Traditionally done obviously using raw iron, which is the material of about 100 years ago and beyond, and it's basically layers of nearly pure iron and smelting slag. And the idea is when they manufactured this stuff, it was basically rolled over in layers to form a kind of laminate. And this laminate, basically the iron itself provides the metallic content. The slag itself has very little structural value. But when you bring the iron up to a high temperature, it doesn't burn as readily as modern steels do. So the idea is, I'll play a little video for you now. You heat up the two pieces of iron to a high temperature, somewhere in the region of 1,000 to 1,200 degrees centigrade. You bring the two pieces together, and as you'll see in a moment, you then drive the two pieces together. It's rather similar, I suppose, to modern impact welding, I suppose. And the thing you've got to bear in mind from this video as well is that the temperatures these men are working in are tremendous. As I say, imagine something that size at 1,000, 1,200 degrees centigrade. As I say, that this probably wouldn't work. You probably couldn't do this nowadays with modern steel, certainly not using a traditional forge, mainly because to bring it up to that kind of temperature at that size, you'd have to heat it very gradually. So it means you have to hold a welding temperature at 1,000 degrees for an extended period in a relative high oxygen environment. You'd actually burn off a lot of your alloy content. I think that's stopped. Yeah. So nowadays, forge welding is still used by modern blacksmiths. To a certain extent, it's used in heritage restoration. There are a couple of people that still produce wrought iron, but it's relatively unusual. It's about 5 times the price of conventional mild steel. You can forge weld mild steel. There's a photograph there on the bottom right of an attempt that I had about a year ago at forge welding some mild steel, and I accidentally oxidized the surface of the steel, and the two just wouldn't go together. And yeah, and of course the other thing you get from wrought iron that you don't get with modern steels is the slag layers provide a kind of flux. So not only do they prevent the steel from oxidizing, but they help to keep it clean as well. Nowadays, apart from heritage applications, forge welding is used in production of things like Damascus steel or pattern welded steel. Damascus steel isn't quite the correct term for it. So you see a picture of an example of that on the top right of the slide there. It's basically layers of different grades of steel. It was traditionally used for production of swords, I suppose the most famous being the katana, the Japanese samurai sword. And nowadays, knife making and blade making has enjoyed a bit of a resurgence, so it's become more popular. I think that's everything for that slide. Okay, now this one, as I said in the first slide there, the first video, you don't really get a picture of the just how much heat comes off something that size. You could barely stand near to it. But also, what you can't really see from the video is the fact that there's a heck of a lot of sparks and shards of molten metal flying off it. So I'll just play this video. This is taken from me on this training. And you can see the amount that flies off it. And this, I suppose, is the benefit that modern engineers have over traditional blacksmiths from a health and safety perspective. That's the next slide here. This is another process entirely. So this is the shodding of a traditional wooden cartwheel. So what they used to do was they would heat up the iron tire, and they would basically to expand it. It was usually done in a peat fire to prevent burning of the iron. They would then lift it up using these hooks, these forks, lift it over the timber wheel, and then they drive it down with hammers once you've got it lined up. That's the tricky part. And of course, you've got to move very quickly, otherwise you'll burn the wheel away. Because this will be around an estimate, I would say, somewhere in the region of 600 degrees centigrade. So obviously it won't take long to burn the wheel away. And the idea is then once the tire is on the wheel, it starts to cool, and in cooling it contracts, shrinks around the wheel, and tightens around it. It actually has the function as well of pulling the frame of the wheel, the construction of the wheel together. So it's not just a high wear surface to the outside of the wheel. But that's an example of a traditional interference fit, whereas we might use liquid nitrogen for cooling nowadays. In those days they used heat. So in terms of what blacksmiths do nowadays, well, I think I've already mentioned heritage and restoration. So stately homes, there's a lot of work for churches, things like that. It's quite niche, and as I say, there's a few people that still produce traditional wrought iron, and as I say, it's very expensive. Nowadays, I would say the bulk of the work that blacksmiths do, and it's certainly what we do a lot of, is architectural ironwork. It's the bulk of our business. Unfortunately, I suppose most of that work is done using mass-produced components. So there's a gate that we made very recently on the far left there, and that has been built using the 4 scrolls on the top, the curls, if you like, were bought in. They were made in Singapore. They're mass-produced on a machine. And unfortunately, it is a lot cheaper to do it that way, and some of the work actually is very good. I mean, we go to some of the best suppliers that we can find anyway. So the quality of the work is pretty good. It's not as good as something that has been truly, fully hand-forged, but most people are happy with that slight compromise in quality if it's cheaper. There is, however, still a market for artwork and niche architectural artwork. So there's another picture there of an example of something that's been entirely forged and handmade. We've picked up some work like that, but it's you can charge more for it. I think the profit margins are probably less because it is so time consuming. There's a limit ultimately to what people are prepared to pay. But ultimately, I suppose it's that kind of work that keeps the craft alive. And then, of course, we've got things like industrial forging, such as shackles, chains, rings, tubes, that sort of thing for special applications, high-stress applications. To be honest with you, that's not the sort of thing that we would do. I think the majority of small blacksmiths couldn't do something like that. The majority of that work is mechanized and automated. And I should mention, really, blade making as well seems to have enjoyed a very significant resurgence in the last few years. I'm not entirely sure why it's necessary for people to make swords, or if they feel it's necessary to be heavily armed, but certainly when I first started as a blacksmith, blade making wasn't such a big thing as it seems to be these days. And everybody I spoke to, you know, a lot of people anyway, when I mentioned that I was a blacksmith or trained to be a blacksmith, the first thing I'd ask you is, oh, do you make swords? To this day, I don't fully understand why. So, in terms of the future of the blacksmith, I think that blacksmithing has enjoyed a resurgence in the last, I would say, in the last 20 years. I've certainly noticed a difference in the last decade or so since I started training. And I think that's mainly because people in this country, and I dare say in other countries as well, are starting to appreciate the benefits of something that's artisan made over something that's been turned out by the million on a machine. And to a certain extent as well, mass production has made life easier for the blacksmith, as I mentioned before, turning out components and so on. There are some things like the spikes you see on top of gates with a railhead, and they're actually fairly tricky to make by hand. You'd have to get them cast or drop forged. So the mass production of them has made the blacksmith's life a lot easier and has taken a lot of the drudgery out of it. That having been said, there are new technologies that may well spell not the end, but certainly a further decline or a future decline in the craft. Things like 3D printing and improvements in manufacturing, that type of thing. It may even be that machines in the future can match the quality of the blacksmith and artisan makers, craftsmen. But I would say that until machines can do the job of the blacksmith in their entirety, there'll always be a demand for their skills. So the next question is, and you're probably wondering this, how is what I've just told you relevant to modern working mechanical engineers, to mechanical engineering profession? Why am I doing this presentation to the wrong institution? The reality, I think, is that, well, for a start, I think that the work of the blacksmith is ultimately where modern engineering, modern mechanical engineer came from. It's the first mechanical engineers were blacksmiths. If you go back to the start of the Industrial Revolution, so it's as well to know where we came from. I also think that echoes of the craft, the ways they approach things, is actually fairly similar to how we do things today. The art of blacksmithing, the craft side of it, the intuitive side of it, is something that's not taught in engineering. But I think from my experience working with older, more experienced engineers, I think that there are elements of it that come through experience automatically in themselves. And we'll talk about that in the next slide. And for that reason, I actually think that this is the reason why I think it's not that great a transition between blacksmith and engineering. The attitude, the way you approach the work is actually fairly similar. So here we have an example. This is me trying to put across what I'm talking about. It's fairly woolly, I suppose, in a way. So some of you may consider it slightly controversial. The more analytical engineers watching this will probably shake their heads, not understanding. Some of the older engineers, the engineers who worked in design, may agree. Basically, the point of it is that as my old blacksmithing tutor used to say, if something looks right, it probably is right. So if it looks like it's going to work, it might work. And you can argue that in modern engineering, well, our science and our analysis is strong enough that we don't need to use intuition in design. But I wonder if how many engineers watching this who've done design work, who've carried projects through, how many of them have never seen anything go wrong, even with the benefits of our modern science. So is our science really mighty enough that we can ignore some of the lessons that I think crafts like blacksmithing can teach us? And I've provided a few examples here, not modern examples to try and avoid too much controversy, but some examples over the last 100 years or so of things where you can see just intuitively by looking at them, you can see what would work and what wouldn't. I guess it kind of reinforces the point. So the first one we've got there on the left is an early Great Western Railway engine. I think it was designed by Isambard Kingdom Brunel, and it was a bit of a disaster. And it does look like it was made of Meccano. And at the top there, we've got one of the most successful steam locomotives, the LMS Black 5, the William Stanier class engine. Then on the next one along, a fairly clear example as well. The reason that the bottom middle photograph is only a painting is because that bridge collapsed. That's the Tay Bridge. It failed basically due to a lack of our understanding in metallurgy. It wasn't physically strong enough. We didn't understand enough about fatigue and brittleness. And the top is, of course, a picture of the Fourth Rail Bridge, which was designed following the disaster of that bridge collapsing, and is still there today. And you can see, I would say, just by looking at it, which one's going to stay up. The one on the right there is an example from during the Second World War, the Avro Manchester, which was a bit of a flop, really. It was the forerunner to the Avro Lancaster, which is the one at the top, which is a very successful British bomber. The Avro Manchester just didn't have the power, didn't have the lift, and it does look, if you look at it, it does look rather heavy and cumbersome. It's not got enough power, it's not got enough lift. And as I say, in all cases, well, certainly the middle two, the middle one and the last one on the right there, they did have a certain amount of science to base their judgments on. Any questions?
Okay, so let's have a look in the pod. See if there are any questions. There we go. Okay, so John from some 1 sub C. Is there an argument that repair is greener than scrap and make new? Research evidence. Let's see. Is there an argument that repair is greener than scrap and make new? I would say so. It's not really something that we think too much about. I mean, most of what we do, we buy in the materials we need and then we build, mainly because if we reuse recycled materials, there's no real guarantee, especially if you're using high-grade materials, so things like spring steel and so on, there's no guarantee that the material isn't damaged. So spring steel, things like that, you know, there's a good chance that there'll be fissures and cracks and so on due to the abuse that it's had. I mean, I've had that experience trying to make chisels and things, you know, as part of my training, making chisels out of old springs, you know, you've picked up from the garage. Basically failed, dumped, and you make a chisel out, realize it's perhaps there was a crack. In terms of what we do for clients, which is definitely using mild steel and structural steel, I would say again, the risks of failure or something going wrong are such that, you know, if you use recycled steel, you don't know what it's been through. I would tend to err away from that. I would tend to err on the side of caution and buy in the steel that we need. And you're absolutely right. It is greener. There's absolutely no doubt about it. to try and recycle. It's terrible in terms of its carbon footprint in manufacturing. So for some reason, we've got into slight IT problems here. Right. Somebody called Robert from Colts Mill Limited, probably down to the TV program Forged in Steel, which, although based in the US, is compulsive watching. This will be to do with the production of knives and swords, and I've seen that program. Yes, and I know what you mean. That will have certainly had an effect, but I'm pretty sure that program came about because they knew that people would watch it, and certainly when I started, it was well before that program was dreamt up. But you're absolutely right. There's something, I don't know, maybe a macho image or something that goes with. I don't know what it is. Yeah. Somebody called Timothy, the Foot of Iron. Blacksmithing is not taught, on the slide, but not discussed and vastly wrong in general context. In general, I'm not quite sure what that's actually asking. Blacksmithing is not taught. I'm sorry, I'm not quite sure what that's about. If you maybe elaborate on that slightly, I'll try and answer that. Somebody called Owen. Are there any recent technological advances that have aided rather than hindered the craft? You mentioned 3D printing, for example. I'd imagine the capability for rapid prototyping and manufacturing traditional impossible geometries for casting might be beneficial. CAD might be another example. Now, that's absolutely right. I mean, if you look at the benefits that we've gleaned from the mass production of certain components, things like the scrolls and so on I was talking about earlier, that come from the Far East. Yes, I think that's absolutely right. We could actually benefit from these new technologies. However, if you look at something like 3D printing, if it is possible to completely 3D print an entire assembled unit, then there's an argument that says we don't actually need the blacksmith. As I say, until such time as these technologies can replace the blacksmith entirely, then there will be a demand for blacksmiths. I haven't seen anything recently in terms of new technologies that have really made a difference. In terms of making our lives easier. Beyond, as I say, the quality of some of the mass-produced components is actually very high. It almost negates the benefits of entirely hand-forged components. Here we go. Certainly a lot of questions coming in. Somebody from Indonesia, University of Indonesia, Yunus even, apologies. Based on your experience as a blacksmith, is there any advantage over old methods such as in sword making, since the majority of sword makers still stick with the old ways? Well, it's interesting that you mentioned swords. Now, this is really, it opens up a can of worms, really, because there's a lot of debate about whether a forged blade is better than what they call stock removal. Basically, you take a billet and you grind off the sides until you end up with a blade. The reality is that, I think anyway, I think this is true, if you forge a blade, you crystallize the outside edge of the blade by virtue of the fact you're pounding it, you're hammering it, and you fill it with a microcosm of little cracks, which improve its edge retention and its impact resistance. And also, I mean, you say the old ways, of course, and some of the old ways of making swords have been lost. Damascus steel, true Damascus, is made out of something called wood steel, which to my knowledge, even nowadays, we haven't fully been able to replicate even with our modern technology. Nobody knows how it was made. But it supposedly has these wondrous properties. There's stories, I don't know how true they are. There's stories of cleaving rocks with these swords and things like that. So it's pretty wondrous stuff. As I say, those skills have been lost. Somebody called Matthew. No questions, but thanks for a very enjoyable presentation. That was very nice of you. Thank you. Okay. Somebody called Barry from Eversholt Rail. How did you justify the own business decision to start? Well, the truth to that is that for many years I couldn't. Whenever I ran any numbers, whenever I considered it, I just couldn't justify it. But in recent times, I've found ways and means. I've gained knowledge from engineering, actually, manufacturing knowledge, knowledge of fabrication and so on, that has made it more viable. And when I actually looked at the numbers, I did find a way that I could make it work. And also, me and my wife are both engineers, so we both had established careers. So we had a bit more behind us. If it did go wrong, we have a fallback. But no, a lot of people, I've heard a lot of stories of blacksmiths who've waited many, many years before they started self-employed, because they perceive there's no money in it. And you won't make as much money in it as an engineer or something like that. Some people have said to me, why don't you just go and get a sensible job? But I quite enjoy the one I've got now. Somebody called Barry. Thanks, Derro. My father this is from Bass Rail Consult, Rail Projects. Thanks, Derro. My father in the 20s and 30s grew up in his father's blacksmith shop in Didcot, which made him a great engineer. Unfortunately, World War II prevented him from getting qualifications for engineering, but he was far better than me with my engineering degree. I don't want to do down degrees. There's a lot of merit in them, but I think that practical knowledge is beneficial. I mean, when I was a student, I used to spend my summers on preserved railways, heritage railways, and I can honestly say I wouldn't say as much, it's different, but I learned a lot through doing that, of actual hands-on handling things, doing things, seeing how things are done in practice, the way you have to approach things and the risks, and just getting that intuition, that understanding of how you actually go about putting things together, which was then very useful in my career when I went into working in marine renewables. Somebody called Michael from Imperial College London. Do you think blacksmithing as a craft can move to become a more sustainable and green, given how energy intensive it currently is? Well, this is actually something we're looking at just now. You can't do anything about steel production itself. That is what it is. But in terms of how we do, there are things like induction heaters and so on that potentially replace the very energy intensive and dirt fires or gas heat. There's no doubt that blacksmithing in its current form is particularly great for the planet. I mean, there's so few of us. I very much doubt that, even compared with something like a heritage railway, I doubt very much that we really do much damage. But we're looking at costs, the type of you see cheaper electricity, which we may well do, like electric cars comes to the fore. We may see energy more widely available and cheaper. Then that may become feasible. I see no reason why not, providing it's affordable. Chris from Independent Technology Coach, that's who he is. You mentioned you were trained. Can you offer any advice, please, about how to find a willing trainer? Is there any national organisation? There are national bodies. There's various colleges that you can go to. I personally, I was trained under a man called William Mowat up in Orkney. He was a fourth generation blacksmith. Unfortunately, he's no longer around. He died at the age of 91 in 2017. So I'm afraid he's not available. But there are smiths around who will train. If you're interested in being trained, I would suggest, if you've not done it before, go and do one of these weekend courses. A lot of forges will offer training days and things like that for a fee. It'll cost you, I don't know, £100 or something like that. It's probably more to cover the insurance and anything else. And they'll give you a go, and you'll get the chance then to see if you like it. Do you want to do this every day? And then beyond that, as I say, there are college courses, and if you can find somebody to look after you, you should get there. There's no, as far as I know, sort of formal training program as such. It's not a case of, in order to be a blacksmith, you have to achieve certain grades or anything like that. It's not like being a chartered engineer or something like that. As compared with farriers, people who shoe horses, you cannot shoe a horse without having certain qualifications. But blacksmiths, there's no such restriction. So there has been talk of that. I don't know if it's ever really going to come to anything. But for restoration work, so the really niche stuff, repairing wrought ironwork in churches and stately homes, there's been talk of introducing restrictions. You have to have a certain ticket in order to do the work. But I don't know if that's more kind of protectionism for people who already work in that area. But hang on. Somebody called Adam from DSTL. Does making or fettling horseshoes not come under the remit of a modern blacksmith? Well, that kind of ties in with my previous comments. That's actually a separate training program. You cannot shoe a horse, certainly, legally, without being a qualified farrier, which is a separate thing nowadays to a blacksmith. I don't know many people who do both, who do both horseshoeing and work full time as blacksmiths. I think it's about 7 years to be trained as a farrier as well, specifically. Alexander from Nissan Motors. How does the modern knowledge of materials and metallurgy feed into the role of a blacksmith? Probably nowadays, probably very little, because most of what we do is it's relatively unstressed components. Unless you work on the industrial forging side of things, making higher stress components, shackles, that sort of thing. I wouldn't say that we're that hung up on the details of metallurgy. I don't think it's really a significant thing. It certainly helps to understand things like precipitation, hardening, and things like that. And it helps to understand what's going on in the background. Whereas in the past, blacksmiths worked purely by intuition. Nowadays, we understand what's going on. So I suppose it helps, but I don't think it makes a vast difference. I think that's what else I can say on that. Somebody called David from Catalyst PWR. How much is there in common between blacksmithing and the current work of Sheffield Forge Masters, for example? So in other words, the heavy industrial forgings. Well, it's simply a question of scale and risk. I mean, what they do is, as far as I'm aware, at Sheffield, is largely, maybe not automated, but is remotely controlled. There's no need for anybody to approach a big slab of hot iron with a sledgehammer, unlike what used to happen. My previous slides, showed an example of that, what they used to do. They don't do that sort of thing anymore, probably from health and safety point of view as much as anything. It's probably a lot easier for those people nowadays. They push a button and something is driven or flattened or whatever it is they do. So, I mean, what we do, I suppose, as blacksmiths, on a small scale, a sort of cottage industry scale, the processes, the techniques are the same. They're just far, far smaller and significantly safer to do as someone with a hammer. That's probably what I can say to that. Man Jun Lee, Curtin University. One of the things or customization that the blacksmith can do, but a machine can't. Well, if you consider, for instance, scrolls and decorative components, we can get a much better finish. And of course, we, by we I mean blacksmiths. So if you buy in a machine-made scroll, the center of the scroll will be jagged because it's been gripped on a hydraulic press. And it will also have been, usually formed cold, so it will have been ripped around the back of this former, and you'll be able to see the sort of serrations, the tears in the steel from where that's happened. So in terms of quality, that's really I would say one of the big differences, is his finish and damage to the steel for forgings, or supposedly forgings imitations. Jeffrey Booth, chartered engineer. To what extent do you need a knowledge of iron or carbon metallurgy to support your work? And then just thanking us for the talk. Well, this is very similar to the question earlier. I would say that it helps. It takes away the sort of rules of thumb, the blind rules of thumb from the past, the pure intuition. But at the same time, I wouldn't have said that it's actually fundamental. It's not vital that you have that kind of knowledge in order to carry the work out. Somebody called Philip from Overview Limited. As an apprentice, I did hand forging. I think it gives an understanding of material behavior which is useful in design with modern materials. Do I agree? I would say definitely. It gives you an intuition about how the material works, how it behaves, what happens to it. If you're experienced in bending a piece of steel or working a piece of steel, you understand how it would fail. You understand also if you're telling somebody else to do something, maybe not forging so much these days, but if you're telling someone to do a piece of work, it helps if you actually understand how they're going to go about doing that piece of work. So in short, I would say yes, I do agree. Yeah. Somebody called Ben at Cavendish Nuclear. Where do most of your customers come from, and are you kept fully busy? I hope, Ben, you're not looking to start in competition with us. But most of my customers are fairly local, actually. I mean, we have an online shop which brings in a proportion of our income, which sells nationwide. We do a lot of the commissions for people in this sort of local area. We're based in Inverness. So Inverness, and we've had commissions of the West Coast, and I would say within about 100-mile radius of us. So we are actually kept fully busy. I mean, really from last summer onwards, we've not really had a break. We've just had jobs coming in. I keep thinking, there'll be a break coming up now. I've not had any inquiries for a few weeks. And I'm getting through the jobs I've got, and then suddenly two arrive, and then suddenly one turns into a live project. And it seems the longer that goes on for, the bigger the jobs get as well. We've got a ton and a half of railings coming up. Yeah. Somebody called Rory. What work are you involved with now being a blacksmith in 2021? Well, it's architectural ironwork, if I've understood that correct. It's architectural components, so gates, railings, balustrades, that type of thing. We get oddballs as well. I've got one just now building a cover for a pond. A lot of it is safety related as well. It's concerns about, it's usually people who've got grandchildren that are going to come around, and they're concerned that in this instance the grandchild is going to fall in the pond, things like that. Well, I'm in college. What would you recommend is the best into blacksmithing? Find a tutor, find someone who'll train you. Ideally, someone who's a trained blacksmith themselves. There are, as I say, college courses, which are supposed to be. I've never done one. Yeah, if you're interested, then find a blacksmith, and also find out for sure if you want to do it. It looks bad, but nobody who's a blacksmith goes through their training. At some point, you'll get. There is an unpleasant side to it. Somebody called Barry from Ever Short Rail. I think I had a question on you before. As in, did you specialize in a known market or go general and hope for the best? Okay. Well, we approached it really. We started out by going online, trying to sell online, because just through the likes of we shouldn't mention the names, but online retailers that you can market craft components on. So we started with them, and basically just to see what we could glean from that. So we made things like fire irons and garden ornaments and things like that, small things. Which allowed us, they're not too big and cumbersome, so while we're getting set up, it was relatively easy to make these things. And then we started pushing for the architectural side. And we're going to keep pursuing the purely bespoke, so artistic ironwork side of things. There's less of a market for that up here because we are relatively remote. But there's a few big companies that do this sort of thing, relatively big companies who do this sort of thing down the Scottish borders and in the north and south of England. Okay, Robert from the IMechE in Switzerland. My wife's father is a master artist blacksmith in Leipzig in Germany. Some of his work is in the domain of very intricate and stylish wrought iron pieces. Yeah, I mean that is that's really on the purely decorative, purely forged artisan ironwork. As I said before, I'd say generally you don't make as good a profit margin. There is more money in it, but it's so time consuming that you probably don't make as much per job, or proportionally as much per job. But it's certainly more interesting, and it keeps the craft alive. So it's great to see that. At the systems, is it coal forge? And if so, what are the advantages over gas? Well, this is a whole can of worms. There's different arguments. I mean, my tutor used to say that he reckoned a gas forge would poison the steel, but there's those who would argue the same about a coal forge. I think it's much of a muchness, to be honest with you. It's down to personal taste. I mean, the advantage of a gas forge is it doesn't burn the steel unless you set it to that temperature. Whereas a coal forge, if you leave a piece of steel in the forge for a length of time, walk away, there's a good chance that when you come back, you'll pull it out and there'll be a firecracker on the end. It'll just be on fire. It'll get too hot if you leave it in there. So there is that, but then at the same time, if you're doing a lot of forge welding, things like that, a coal forge is definitely better because you can get that localized heat very quickly and easily, whereas a gas forge is a more general heat. Hang on. Somebody called Alan from Vision International. I've watched the Forge Masters. They sprinkle a powder over the metals they're about to forge together. I assume carbon of some form. What is it exactly? What are the secrets in making it work? Well, that powder is borax, probably. I've heard of people using sharp sand as well. I was explaining earlier about the wrought iron. So you've got a mixture of pure iron and slag. The slag basically forms a flux. And modern steels, you don't have that, which means that modern steels have a tendency to burn, and they also they can get quite dirty, and they can oxidize. All of which is pretty bad for welding. So what you can do is you can sprinkle this stuff onto borax, which basically acts to form a barrier that prevents oxidization and burning, and also forms a sort of glass on the surface that helps to keep it clean. So the idea is then that when you drive the two together, it then goes together. John, he's retired. Very interesting talk. You didn't mention shoeing horses as part of the past or current work of the blacksmith, or is that the work of the farrier? Well, as I said before, it is the work of the farrier now. And as I said, it's not legal to shoot horses unless you have a specific qualification. It's about 7 years of training. Craig from Sellafield, do you think it would be possible to teach the intuitive side of engineering without having to learn a full artisan craft like blacksmithing? Well, yes, it would. It's really just the reason I talk about this is really just to make people aware. As I say, it's something that comes with experience automatically. You don't need to be a trained blacksmith to have this intuition, this skill that builds up over time. But I think it's still important. I think if people, especially training engineers who are graduates, I think they need to bear this in mind. Just sit back and look at something you've designed and think to yourself, does that look like other work? Do my calculations look like, I've done a calculation on a beam that says the beam is strong enough. Does that beam actually look strong enough? And if it doesn't look strong enough, there might just be something wrong with your calculations. Look, I think slight IT problem here. I think that's it fixed now. Do you think that blacksmithing training changed their approach to engineering work, and can I give an example? I'm struggling to think of an example. I mean, it certainly did. There's no doubt about it. But then I also had the benefit of some of my sort of hands-on training on the railways, the heritage railways, when I was a student. So I think certainly there's been a few projects I've worked on where I spent a bit of time trying to make the design work in the past. I've tried to make what I'm designing look good, which is more for the client's benefit or my employer's benefits as much as anything. But I think that has come about to a certain extent as a result of the blacksmith training, because the blacksmith is slightly more focused on aesthetics, I would say, in the area I work in anyway, than a lot of engineers might be. So it's probably that. I can't really think of anything specific. I'll see if I can think of something before the end of the webinar. Peter from Recycled Products Limited. The traditional form is very energy inefficient. you see a move to directed heating? Heating, absolutely. If we can make it work on the scale we have, environmentally friendly, then we will do. If we can afford it, obviously, that's the other concern. Is if it's a very expensive piece of kit, that might be a problem. But yes, absolutely, if we can, we will. I've got another one there saying thank you very much for the presentation. That's Paul. Somebody called Julian. What do you think about the scope of blacksmithing as a hobby, a bit like pottery and glass blowing? Well, a lot of people do it as a hobby rather than as a profession. I mean, it's not an easy job if you do it 5 days a week, 52 weeks a year. So I would say if you're interested in it, you enjoy it, you enjoy trying to then you can be a professional blacksmith if you pursue it. I would say the critical thing, if you're just going to try and teach yourself, is try not to grip the this presentation, but it is as this album. If you really don't have to hard is off the end, from rhythm, but other than that, it's what see. Intuition is good design. You use design tools to design intuitive thinking. As a first, I entirely agree with that. We do tend to use analysis packages as a black box as well. You know, you put your design into the analysis package and then it pops an answer, and we assume because it went into that reputable package that somehow the answer will be just as reputable, and it's not necessarily true. William Spice, do you think that will affect the blacksmith in 10 years' time? Well, in terms of things like coal and so on, yeah, I think that will probably have an impact on traditional work using coal forges. But as I say, we don't have to use coal forges. There are induction heaters and things like that, providing they're affordable and economical. I can't see any restrictions on the supply of steel. I mean, okay, steel production is pretty bad for the environment, but we still need it. So somebody somewhere is going to continue to produce it. So I think it will. There will be problems, but I think we'll overcome them. Stephen, have you had to change any of your working processes to comply with modern day HSE requirements? Much on the forging side of things, but in terms of welding and so on, a couple of years ago they decided that welding is actually bad again. We've known this, so we used air-fed helmets and things like that, and air extract systems. There is a slight problem as well. Coal, if you're burning the coal forge, it does produce smoke. To make sure that's I don't think it's really changed the processes. You have to wear safety specs for that. My training actually recommends forge welding, which is pretty incredible to think if you look at how much flies off in welding. But you reckon the glare from the fire and the iron would spoil your vision with the safety, which is true to an extent. But it's the lesser of two evils, I think. I think you should learn because, okay, you maybe can't see quite as well. But you don't want to get any of that in your eyes. Robert, again, I would like to send you a few photos of his work. Okay, that's absolutely. By all means, send that through. I could take an email. Charles Melton, formerly a technical director. Is there an example of a product you've made or an application of any modern engineering design processes we used? Or is everything the blacksmith does based purely on intuition? I think it's like my tutor used to say. The difficulty with me was training the engineer out of me to sort of superimpose the blacksmith on top. So I would say I approach everything to a certain extent as an engineer. That hasn't gone away. I mean, I've been working as an engineer ever since I started training and since I finished. So it's hard to be very specific about it, but I would say that I approach my work, especially when I'm building gates and railings and so on, I would approach that work in much the same way as a fabricator. I also, something that's sort of fallen through from my engineering time, when I speak to a client and when I agree a job, by the time we agree the job and the price, the client has a full drawing of what it is I'm going to build, which is fully designed out with every section size and everything, so that I know what I'm building and they know what they're getting. And I think that's something that's come from my time as an engineer. I don't think many blacksmiths actually do that, but to me, it's everything, that specification that I stick to, I think is very important. I think that's come out of my time as an engineer. I'll see if I can squeeze a few more in here, a few more questions. Andrew from Cavendish Nuclear, quality, i.e. British-made blacksmithing tools still available? I'm thinking of picking up as a hobby. Well, just keep looking around. Blacksmithing has had something of a resurgence in recent years, so a lot of these things are being snapped up, but at the same time, a lot of people have started it and then decided it's not for them. So occasionally you'll find an entire forge where the equipment comes up for sale, so just keep looking around. And there are people who make these tools as well, and they're decent quality. So if you do a bit of a Google search, you'll see. Simon from BT, test specialist. How has the method of heating the furnace changed over the years? Well, in the past, they used to use mechanical bellows, which are hand cranked, hand pumped. Nowadays, we tend to use electric blowers. So that's for heating, and that's for coal forges. For gas forges, gas forges haven't been around that long in sort of small scale blacksmithing, so there's not really been much of a change there. Somebody called Alan from SKF. Glad you raised the topic of intuition, even from a visual assessments and often based on my feedback on such intuition has not been wrong yet. I started off in my early teens as a blacksmith's apprentice and now an R&D engineer. Well, there's somebody obviously who agrees, who has the experience. Yeah. Well, I completely agree with you. Somebody called Michael from Cranfield University. What do you use for heating fuel? Any thoughts about zero carbon emissions, electric or synthetic fuels? Well, you can get smokeless fuels, but obviously that doesn't eliminate CO2 emissions. Electrics, definitely. I'm not entirely sure what that's about. Synthetic fuels. I'm not entirely sure what that is, but as I say, the big three really are coal, gas, and electric that I'm aware of, anyway. And obviously, gas and coal are not particularly environmentally friendly. Let's read this one. Matthew. Do you get involved in production for films, TV, theatre, sets, props, etc.? I did, for some reason, a few years ago, have somebody come through asking if I wanted to be involved in a film with Angelina Jolie, but I didn't, and in some ways I'm glad. But no, not generally. There was a documentary made about the forge when I was training. The forge where I trained is a museum. Yeah. So anyway, I think that's 1 o'clock, so we have to finish about now. Thank you for joining us. And if you've got any further questions that you really want asked, I'm sorry I haven't been able to get to everybody's, you can contact us at contact@highlandforge.co.uk. If you'd like to just drop us an email, I'll try and get back to you. Thank you.